Hello all, welcome back to Dev Sir's Mathemagic. Yet another session for Maths MHT CET 2026. We continue with our series. Soon after finishing derivatives, we'll take up some other topic. So today I am taking PYQs from 2018 and 2019. Okay. Let us go to the first sum from 2018. X is equal to root of a sine inverse t, y is equal to root of a cos inverse t. Find dy by dx. Four options were given, but I haven't written over here in order to save certain space and time. Okay. Now, key step, you just have to remember certain key steps. Eliminate parameter t from both equations to get these two equations. Then add both equations. Just remember, now if you remember the hints, if you get a similar sum in CET, just go to these two equations and the answer will be over within 1 minute. As I said, the speed is important. Okay. So eliminate parameter. These are parametric equations as we have seen. Okay. X and y, two variables. T is called as the third variable, which is called as the parameter. So yesterday I explained that in certain equations, parameter can be eliminated, t can be eliminated, so that the equation becomes simpler and time is saved. Okay, no need to find dy by dt, dx by dt and then use the parametric formula. Same case over here, eliminate t. Now I have taken again two sums, one is this and the other is this. Let me explain the difference between the two when we get to this. इसको टेक्निक कौन सा है, इसको टेक्निक कौन सा है, right? So I am getting these two equations. Okay, so x squared upon a is equal to sine inverse t and y squared upon a is equal to cos inverse t. ये equation आने के बाद parameter t will be removed. So we'll see how that is done. Are you ready? Okay, let's go now. So these are the two basic equations. I am squaring both sides because unless and until I remove the root sign remove करने के बाद, then I will be able to separate out terms. Okay, so squaring both sides, I get x squared is equal to, यहाँ से root sign चला गया, y squared is equal to root sign goes over here. Then, as I said, I am planning for these equations now. X squared upon a. Right? Once you get used to these techniques, eliminating, somehow eliminate t. Now, add both equations. This equation plus the, how do you add? Yesterday I told you, left hand side plus left hand side. Right hand side plus right hand side. Elimination becomes simpler and interesting also. अभी कल ही फॉर्मूला देखा था, sin inverse x plus cos inverse x is equal to pi by 2. Very useful, important formula. Similarly, sin inverse t plus cos inverse t is pi by 2. So I will take the LCM here. पहला LCM लेता हूँ and this is pi by 2. क्रॉस मल्टीप्लाई करो, यहाँ पे ही कर रहा हूँ मैं, समझ में आया? I have taken the LCM here. Sin inverse t plus cos inverse t is pi by 2. अभी LCM से क्रॉस मल्टीप्लाई करो, x squared plus y squared is equal to pi by 2 into a. T has been eliminated. So when t has been eliminated, no need to find dy by dt and dx by dt. Direct differentiate with respect to x. Derivative of x squared 2x. Derivative of y squared, don't forget 2y dy by dx. Y squared का derivative 2y लेने के बाद dy by dx, that we have learnt in boards. Pi by 2a is our favorite derivative of any constant is 0. Pi by 2 is a constant, a is a constant. सो एज कल का जैसा आ गया अभी 2y dy by dx is equal to minus 2x, right? So get the answer now. 2y dy by dx I have kept on the left hand side, 2x I have taken on the right hand side. So 2y dy by dx, so I get dy by dx equal to minus 2x upon 2y. 2 gets cancelled. Final answer is minus x upon y. As simple as that. Followed? So see how fast it becomes when the variable can be removed or eliminated. So let us go to the next sum, which is again parametric, लेकिन यहाँ पे टेक्निक थोड़ा अलग है. प्लीज राइट डाउन दिस सम्स. दोनों इक्वेशंस लिख लो. टेक अ डीप ब्रेथ. Okay, all set. Now let me try to eliminate theta. Now theta is the parameter here. Okay, so theta is the parameter here. So how do I do it? यहाँ पे तो root sign नहीं है ना. So if I try to eliminate like the earlier case, I had taken x squared upon a. So supposing I take x upon e raised to theta is equal to sin theta minus cos theta. Similarly, y upon e raised to theta, I am explaining. Y upon e raised to theta is sin theta plus cos theta. You can add the equations, but unfortunately, यहाँ पे theta है देखो, it is not a constant. So, however you try, theta cannot be eliminated over here. यहाँ पे आसान हो गया because a was there, and sin inverse t plus cos inverse t is pi by 2. But that cannot be done over here. Even if you square and add, sin squared theta plus cos squared theta मिलेगा, लेकिन ये e raised to theta का क्या? I mean that third variable will be there. It cannot be eliminated. That is how you recognize. If you had a constant here, maybe yes, that would become simpler. But e raised to theta consists of an variable. So इसको elimination नहीं चलेगा. इसको रेगुलर मेथड ही यूज करना पड़ेगा. दैट इज व्हाई आई टुक दिस प्रॉब्लम साइड बाय साइड टू रिकॉग्नाइज. सो रेगुलर मेथड भी नॉट डिफिकल्ट. कंसिडर द इक्वेशन ऑफ y फर्स्ट. नाउ डिफरेंशिएट विथ रिस्पेक्ट टू थीटा. राइट हैंड साइड को थीटा है, सो dy by d theta. Now you have a multiplication sign here. So first function derivative of second plus second function derivative of first, our favorite product rule. If you have a multiplication sign here, then don't say derivative of this plus derivative of this. No, first function derivative of second. See how I write. First function e raised to theta. इसको लिख रहा हूं, second डायरेक्टली करेंगे. Derivative means d by d theta now, not d by dx. Differentiate with respect to theta. So first function derivative of second plus second function derivative of first. Now in CET you are not expected to write this. फटाफट कैलकुलेशन करना है. प्रोडक्ट टूल आज फर्स्ट टाइम यूज कर रहे हैं फॉर मोस्ट ऑफ यू, सो आई एम जस्ट एक्सप्लेनिंग दिस. राइट, सो शैल आई कंटिन्यू हियर नाउ. प्रोडक्ट टूल यूज किया है, क्या आ रहा है देखेंगे. इसका तो काम हो गया है. Okay. You might think that this is lengthy and all, not at all. dy by d theta. Now, plus means you are allowed to open up the brackets and take the derivative of each term. D by d theta of sine theta, cos theta, plus d by d theta of cos theta minus sine theta. Just take d by d theta inside. डेरिवेटिव अंदर लेके जाना और इसका डेरिवेटिव दे दिया, प्लस साइन थीटा प्लस कॉस थीटा वैसा ही है, बिकॉज फर्स्ट फंक्शन डेरिवेटिव ऑफ सेकेंड फंक्शन वैसा ही रखना, डेरिवेटिव ऑफ फर्स्ट. नाउ डी बाय डी थीटा ऑफ ई रेस टू थीटा, डेरिवेटिव ऑफ ई रेस टू एक्स इज ई रेस टू एक्स विथ रिस्पेक्ट टू एक्स. सो डी बाय डी थीटा ऑफ ई रेस टू थीटा इज ई रेस टू थीटा. साइन थीटा प्लस कॉस थीटा वैसा ही रखो. तो ये सब dy बाय डी थीटा आ रहा है अपने को. अभी मैं क्या करने वाला हूं, आई एम गोइंग टू टेक ई रेस टू थीटा कॉमन. फ्रॉम बोथ, what remains here? Cos theta minus sin theta plus sin theta plus cos theta. I mean, these are not two equations. I'm just adding the terms by taking e raised to theta common. So minus sin theta plus sin theta गया. Cos theta plus cos theta. So what is it that I get? Two e raised to theta cos theta. Right? Now dx by d theta. Let's see. I'll just mark this. Now dx by d theta. Now, while solving CET, this is how you are going to do this now. X is equal to this. So directly करना है dx by d theta. See the difference in boards and CET now. Direct mind में first function derivative of second e raised to theta, but focus. Derivative of sin theta minus cos theta. Derivative of sin theta is cos theta. Derivative of minus cos theta is plus sin theta, because derivative of cos is minus sin. Okay. First function derivative of second, right? Plus second function यानी वैसा ही रखना है. Derivative of e raised to theta is e raised to theta. Take out e raised to theta common. Yeah, same. I am adding these two terms. Now do this orally. Cos theta plus sin theta minus cos theta cancel. ये सब like this. This will speed some things direct. 2 sin theta. So 2 e raised to theta sin theta. dx by d theta आ गया. Now our regular parametric formula. Okay, क्या parametric formula है? dy by dx dy by d theta upon dx by d theta Just substitute the answers. dy by d theta, two e raised to theta has got cancelled. So dy by dx cos theta upon sin theta, cot theta. So what is the question asked? Find dy by dx at theta equal to pi by 4. Pi by 4 is 45 degrees. 10th standard you know, tan 45 cot 45 is 1. That is our answer. So in certain cases, you have to use the regular method when you cannot eliminate the variable theta or t. Variable separation, कल का problem और आज का problem में से we removed t and then we use the direct method. लेकिन यहाँ पे parametric method. Followed the difference? But even while doing parametric method, you have to use product rule and all those things orally, like we did in the second equation. Okay, so try this sum again. Should be able to finish this within 1 minute. बाद में try करो. Let's go to the next sum. Okay. So what does the problem say now? This is from 2019. Very sweet, simple and interesting sum both. देखने में complicated लगता है. Okay. Now your process of thinking. Process of thinking क्या है कि sin inverse, cos inverse में whenever this term is given, okay, cos inverse के सामने ये है. Try to get the same bracket over here. Or another thing I'll tell you. You have got cos inverse over here. Convert cosec inverse into sin inverse. Keep things simple. Cosec inverse, why do we require? Convert into sin inverse. Now I'll explain another trigonometric, inverse trigonometric formula which you have already learnt in the 12th standard. Here itself. देखो. The hint is convert into sin inverse. Okay, convert into sin inverse. So if I convert cosec is the reciprocal of sin, sin is the reciprocal of cosec. So if I convert into sin inverse, all that you have to do is you have to take the reciprocal of this. इसको उल्टा करना है. Because sin inverse x is equal to cosec inverse 1 upon x. That is the rule. Okay. So if you just change this into its reciprocal, you have to take the reciprocal of this also. तो ये ऊपर अभी ये दोनों सेम हो गया देखो. Why did I write same? Think. Very interesting thing. इसके बाद 2 मिनट में, 2 मिनट भी नहीं, 1 मिनट में सम खत्म होने वाला है. 1 मिनट भी नहीं, हाफ मिनट में. याद आ गया? कल किया था वो, अभी भी किया था. Sin inverse x plus cos inverse x is nothing but pi by 2. Instead of x you can have the same bracket, कुछ भी चलेगा. Sin inverse 100 plus cos inverse 100. Sin inverse x squared minus 1 upon x squared plus 1 plus cos inverse x squared minus 1 upon x squared plus 1. When these two brackets are same, sin inverse plus cos inverse is nothing but pi by 2. Problem over. So y is equal to pi by 2, friends. Simple. Differentiate with respect to x, dy by dx. So finished. 0 is the answer. That option was given. So I told you, it is just some problems are sweet and simple, but you have to recognize the techniques correctly. And process of thinking. Brackets क्यों interchange करना है, reciprocal क्यों लेना है. So as to use the formula sin inverse plus cos inverse. Followed? Enjoying CET now. Okay. Let's go to the next one. We'll have one more from 2019. Fourth one. I hope everything is visible properly. This derivative is asked. Okay, derivative of log x bracket squared to the base e. Okay, derivative means we want dy by dx. Okay, so let's write y is equal to naturally variable is x, so differentiate with respect to x. Now remember, when the base e is given, derivative of log x is 1 upon x. Okay, so now just base e is given means you are allowed to neglect it. अगर base 10 है तो you have to use change of base formula, which we will see later. So derivative of log, just close this. Derivative of log के सामने जो कुछ है उसको 1 upon करना है. So derivative of log is 1 upon log x bracket squared. Okay, derivative of this log is over. Derivative of outer log 1 upon जो कुछ सामने है, take that into d by dx of log x bracket squared. So derivative of log x bracket squared, now remember this 2 comes in front into log x raised to 1. First you have to take n x raised to n minus 1 for any function. That is the rule. If sin x bracket squared was there, 2 sin x and then derivative of sin x. In the same way, 2 comes in front, log x raised to 1. This is not the rules of log, confusion nahi hai. I am taking the derivative into d by dx of log x. Basic chain rule. So I am writing this 2 log x ऊपर लिख रहा हूं मैं. Derivative of log x 1 upon x. So the answer given is this. Let me check the options. There is one more simplification. क्या simplification हो सकता है? What is x upon x squared? X upon x squared, 1x gets cancelled. So log x upon log x bracket squared, log x gets cancelled. So final answer is 2 upon x log x. If this option was given, यहाँ पे टिक मार्क करो. If this is not given, then you have to simplify. You have to keep on checking the options given. Okay. So this was the final option given. So we simplified by cancelling 1 log x. Now remember one thing, as I told you, log x bracket squared, you are not allowed to use rules of logs and write this as 2 log x. That is not allowed. That is allowed only for log of x squared is equal to 2 log x. Log x bracket squared को कुछ नहीं कर सकते except cancel 1 log x by simple mathematics, right? Okay, so these small things also I'll be telling you in between. So these were the 4 problems, PYQs for today. We'll continue tomorrow. Keep on practicing. Yes, you require practice and you will require a proper reference book for practice. Get that and start practicing. Daily 2 hours practice maths के लिए चाहिए. My videos are there to support you, of course, but you need to practice lot more. Okay, bye for now. See you tomorrow.